So basically, there are different types of register. 5 register you need to know about. Okay, MAR. The first one is PC. Second is MAR. Third is MDR. Fourth is CIR, and fifth is accumulator. So they are connected to me. Okay. Here descriptions are given. As I discussed with you, CPU has 2 parts. One is ALU, second is C. So ALU perform arithmetic operation. Okay. As it is written, arithmetic and logic operation. Logic operation means compare during programming. And control unit read instruction from memory. This step is called fetch. Okay. Read instruction from memory means this step is called fetch. You remember fetch? We have done.
Yes.
And second step is to interpret. What to do? Interpret them using the fetch, decode, execute cycle. And execute is the third stage. And generate signal for other component. So it means timing, clock. Okay. In these process, every time some register are involved, okay, to perform computation. Okay. So as I told you, a register store data in bytes. Okay. It can be 4, 8, or 16 or 32 byte. Data stored by register basically in bytes. You know about bytes? Any idea?
Bytes are the amount of the storage in
Okay.
registers.
Okay. So minimum storage is 1 byte. Okay.
Yes.
Which store 1 character. So 1 byte means 8 bits. So 8 bit become 1 byte and 1 byte means 1 character. Okay. So register can be 4 byte, 8 byte, 16 byte, and 32 byte. So according to register size, computer speed or processor speed determined. Okay, 8 byte is more faster than 4 byte computer. Now here each register description we last time discussed. CIR, accumulator, MAR, MDR, and PC. As I told you, whenever CPU try to get instruction or try to know on which instruction it has to perform, it will check PC first. It will check PC first because PC hold address of next instruction to be processed. This register store the address where the next instruction to be read can be found. Second step is MDR. Content of PC is transferred to MDR. As I told you, first PC is read, content are stored in MAR. Second step is MAR. This is second. And MDR is third. From MAR, it goes to MDR. From MDR goes to CIR. And from CIR, it goes to accumulator. This is the sequence how register are being used. So MAR, this register stores the address of the memory location currently being read from or written by the processor. Then MAR hold the address of data that to be processed. MDR hold actual data. Okay. This register store data which has just been read from memory or data which is about to be written to memory. Okay. The fourth is, as I told you, CIR. This register store the current instruction being decoded and executed. Processor working on current instruction, it is held by CIR. And the result of processing is stored in accumulator. This is fifth. So this register is used when carrying out ALU calculation. It is stored data temporarily during the calculation. So these are the steps. As I discussed last time also, today I revise it. Here you can see buses. Now here you can see buses. Now here, this is address bus, data bus, okay, control bus. So buses are electrical part. Buses are electrical part. There are three types of buses. Address bus hold address of data. Data bus hold data itself, and control bus hold signal. What we say? Signal. Control signal. Sent to other part of computer by the CPU. So here you can see description. Address bus. It is a unidirectional bus carrying address throughout the computer system. Database bidirectional bus. Okay. It means bidirectional means it can be read, it can be written to a memory, allowing the transfer of data between CPU, memory, and input outputs. All devices are connected with database because input by data send data, output by show the data, and processor process the data. That is why they are connected, and memory holds the data. Now next is control bus. It is also bidirectional bus, carrying signal from the control unit to other component in the mean. It will give direction. CU, the role of CU is kind of director, like drama director, film director, which gives instruction everyone how to perform his or her role. Same thing happen in computer. Control unit tell all part of computer like in what kind of their role. Okay, is this clear?
Yes.
Now fetch, decode, execute cycle. So this thing already we have done. A fundamental cycle. Every instruction processed by these stages. These three stages. One is fetch, every instruction. Second is decode, and third is execute. Fourth is store. A fundamental cycle in CPU operation where instructions are fetched from memory. This is the first step. Decoded means interpret, to translate the instruction, what to do, and then executed to perform particular operation. Executed means to perform operation like plus, minus, okay, minus, divide, multiply. These are kind of operation. Involve the use of address bus, data bus, and various registers.
Teacher, executed means like performing the
To perform particular operation, like addition of two number, subtraction of two number. Okay, to perform, execution means to perform particular operation. Okay.
Okay.
Now in this, one thing is role of system clock. Timing. Timing is sent to every part of computer when an operation will be performed. The system clock produces timing signal on the control bus, ensuring synchronization. Synchronization means same. Every part of computer must be ready during operation of the computer, of data flow and program instruction. Got the idea? So CU continuously sends signal through control bus regarding when to perform a particular operation. Okay. Now there is also one kind of memory, that is RAM. RAM basically temporary memory, hold data. RAM hold data and program needed by CPU for faster access compared to backing store like hard disk. As I told you before that when you open any program, it open in RAM. Okay, every program is, this is CPU. Okay, this is CU.
Okay.
And this is ALU. This processor connected with one kind of memory that is called cache. Did I tell you before? And second is RAM. The RAM connected with cache. These two memory are RAM. Basically, they are RAM. But RAM has two categories. One is DRAM and one is SRAM. Cache basically is SRAM, which cannot be upgraded. But RAM can be graded. DRAM is actually RAM. Got the idea?
Okay.
Now, difference in RAM and DRAM is that SRAM is smaller. But
Teacher, I
fast.
have a question.
Yeah.
What can you explain what ALU is?
No, CPU, no? This is the whole CPU. This is CPU.
No, I am talking about ALU.
ALU, no?
Yes.
CPU has two parts. One is CU and second is ALU. I will tell you the role of both. Okay?
Okay.
Wait 1 second. I draw the diagram, then I tell you the role of each part of component. Now, RAM is connected with hard disk. Here is it written hard disk. RAM is connected with hard disk. The processor can connect with the RAM also. Now, all input devices connected with RAM. Input device. Input device, using input device, we can give the data computer. Which part of computer receive data from input device? RAM. Only RAM receive data from RAM. Why? Because whenever we open any program, it is installed in hard disk but open in RAM. The RAM fills over the period of time. That is why it becomes slow. To cater the slowness of computer, we establish cache memory. Cache memory is faster than RAM. This is basically CPU. Everything processed by CPU. Processor need multiple memories. One memory inside CPU that is called a register, as I told you earlier. Okay.
Okay.
Register hold data in bytes. Cache hold data in megabyte, like 8 MB. Maybe 16 MB. RAM hold data in GBs, like 4 GB, 8 GB, or 12 GB. Hard disk in terabytes. CPU does not deal with hard disk. CPU does not deal with hard disk. It only deals with RAM or cache. Whenever we save data, it always transfer to hard disk. Got the idea?
Okay.
Okay. Now, one thing is saying that importance of bus width. The width of buses, address and data is crucial, as wider buses allow the direct addressing of memory, more memory locations simultaneously. Like, as I told you, register size can be 4, 8, 16, 32, or 64, or maybe 128. 5. Whatever register size, bus width will be same. Okay. If you are using a register size 8 byte, then your bus width will be 8 byte. Bus width means number of lane on a road. Do you know lane? Do you know about lane?
Can I say that?
Lane.
Lane?
Yeah. What is lane?
I don't know.
No? Okay. You live in Saudi Arab?
Yes.
There is a road. There is a road, highway. How many lane in highway when you travel on the road? 2, 3, or 4? Lane are basically path. A road is divided number of lines. So your car will, this is the fast track. This is little faster, more little faster, and this slower track. If your road has 4 lanes, 4 vehicles can move at a time. Okay. So
Okay.
bus width means the same thing is bus width. It can be 4 byte, it can be 8 byte, it can be 16 byte. So if you have 8 byte bus width, it is faster than 4 byte bus width. 16 byte bus width is more faster than 8 byte. Got the idea? So whenever we make a road, okay, whenever we make a road is divided into number of lane. Lane is basically path on which your vehicle move. Okay. So right side is become more faster as compared to left side. Your left side is more faster or right side?
Okay. Right.
Right. Huh? If you travel on right, it is more faster than second track. So lane mean track. This is first track, second track, third track, fourth track. Okay. So bus width is same. If you have 4 byte bus width, it is slower than 8 byte. Got the idea? But I'm telling. Okay. The bus, it says the width of bus's address and data is crucial. It becomes wider. I mean, before you upgrade your computer from 4 byte to 8 byte. So 8 byte is faster than 4 byte. Got the idea? Wider buses mean a number of vehicles can be more move on road. Allow the direct addressing of more memory location simultaneously. So if you have more address and data byte bus width, it will have more number of memory location. Double. It becomes double. Again, fetch, decode, execute cycle. Data and instruction are fetched from memory into suitable register, as I told you. First step, the fetch instruction is decoded for interpretation. Control signal are sent to appropriate component, allowing the execution of the decoded instruction. So this is these 3 steps every time happen whenever you give instruction to the computer. Got the idea? Okay. You can see system buses and memory. Already we discussed data bus, control bus, address bus. So all buses are connected with memory, CPU, input, output. The buses basically play a vital role to transfer data. Buses basically used to transfer. What are the buses? Basically electrical path. Electrical path on which data move. It has a control signal generated by CU, address of data, and database hold data itself. Okay. So buses connect all part of computer inside the computer. You got the idea? What does the buses? Can you tell me what does the buses?
Can you say again?
Can you tell me about buses? What is the role of buses in computer?
The buses?
Yeah.
The buses transfer the signals to the other component.
Okay. So it is electrical path. First, you have to tell buses are electrical path inside the which connect. Buses are electrical path which connect all part of computer with each other. Like CPU connected with buses through memory. Memory connected with input output device. Ports, okay, ports also. Ports mean a connection point outside the computer to connect all input device. All input output device connected through port with the computer. Like USB port, HDMI port, okay?
Okay, so ports are the outside of the computer, like keyboard, right?
Yeah. In laptop, keyboard is already given, but mouse is connected outside the computer. Okay. Scanner connected outside the computer. Camera, printer, all these input output device connect. Mic, okay, headphone, all these devices connected outside the computer, and they are connected through ports. Remember, they are connected through ports,
Ports.
like USB port. Okay.
Yes.
Now here, detail of bus is given. Just go through this one. From here to here. Have you read? This, have you read this para? Read this para, which I marked. Just go through, then I tell you further.
Okay. Okay, I read.
Okay, so what did you understand?
System buses are used in computers as parallel transmission computers, like
Okay.
each wire transmits one bit of data. The train buses in the non one
Von Neumann architecture. Okay.
are
Architecture.
this bus, a data bus, and the control bus.
Okay. So there are three types of buses. Okay.
Yes.
The first one is given address bus. Address bus basically carry address of data. As the name suggests, the address bus carries addresses throughout the computer system between CPU and memory. Okay, because memory has address. Memory has address. So CPU has to pick data from the address. Memory is like that. I show you that. Maybe wait a second. See here. Memory like this. This is memory. One column for address and one column for data. This is data. So CPU need address from on which address it has to work. Okay. Okay. This address has such kind of data. So this address will move by address bus. Address of memory will move by address bus, and content or data move by data bus. Got the idea? Okay. Memory is like, as I show you, this is kind of, so one column is used for address and one column is used for data itself. So memory, it's like, because memory is stored in binary form. Do you know binary?
Yes.
Okay. The computer only understands binary form and it store data in binary form, and these addresses are generated in memory. Okay. That is why it is written there CPU work on memory. CPU consult with the memory. As the name suggests, the address bus carries addresses.
Yes.
At where are the addresses? In memory. This is kind of memory.
Okay.
Yeah. This is address and this is data. Throughout the between the CPU and memory, the address bus is unidirectional because CPU only need read operation. Okay. Bits can travel in one direction only. This prevent addresses being carried back to the CPU. So which would be in undesirable feature. That is why computer engineer made unidirectional address bus. Now again, width bus. The width of bus is very important. Like the wider the bus, it means you can move more data. The more memory locations that can be directly addressed at any given time. So number of memory locations can be increased if you have more wider bus. Example, a bus with 16 bit can address 2 power 16 the number of location. So 2 power 16 means 2 byte, 16 bit means 2 byte. Okay. So these addresses can be generated in memory. Whereas a bus width of 32 bit allow these number of memory locations. The location to be simultaneously addressed. However, even this isn't large enough for a modern computer, but the technology behind even wider bus is outside the scope. Bus width is not part of syllabus, okay? But it is only giving a knowledge. The bus width is very important.
Yes.
Okay. One second. Wait 1 second. Now data bus. So basically, data bus is basically bidirectional. As I told you, memory have 2 columns, one for so there are 2 columns, okay? One for address and one for content. So this is address. First column is address, and second column, as I show you in the previous slide, allowing data to be sent in both direction along the bus. Okay, so data moves on data bus through data bus. This means data can be carried from CPU to memory and vice versa, means memory to CPU, and to and from input output device. Because we give data through input devices and show data from output devices. Okay, got the idea?
Um, and unidirectional means like it can't be carried from back to CPU.
Yeah, bidirectional means you can read data, you can write data. It's here allowing data to be sent in both directions along the bus. Okay, you can read data, you can write data. Got the idea?
No,
Bidirectional, you don't know?
no.
Okay, it says this means data can be carried from CPU to memory. CPU has to read data from memory, and CPU has to write back data on memory. Okay, so this is done by data bus. To and from input output. It is important to point out that data can be addressed, an instruction, or a numerical value. So as with the address bus, the width of data bus is important. Same like the wider the bus, the larger the word length that can be transported. Okay. As I give you example of road. As I give you example of road. Okay. When you have a wider road, okay, your data vehicle can move in faster way. Same thing happen in memory. A word is a group of bits which can be regarded as a single unit. Example 16 bit. 16 bit means 2 byte. Two character. 32-bit means 4 byte. Yeah.
What does unidirectional means?
No, uni, not un. It's a uni. Uni means single. It's uni. So control bus is a unidirectional.
Mm-hmm.
Okay. You're talking about address bus?
Yes.
Address bus, it says it's not undirect, it's a unidirectional. Uni means one, single. Okay. And bidirectional means two. Bi means two. It means bus can be written or read by the
Mhm.
processor. That is why it is called bidirectional.
Okay.
Okay. So bus width important in address bus and also in data bus. A word. Okay. A word is a group of bits which can be regarded as single. Like 16-bit word mean two character, 32-bit mean 4 character, 64-bit mean 8 character. Word length are the most common. So larger word length can improve the computer overall performance. Got the idea?
Okay.
Okay. Control bus which send the signal. The control bus is also bidirectional. Okay. It carries signal from the control unit to all other computer components. So it is usually 8-bit wider. So there is no real need for it to be any wider since it only carries control signal. The control bus can be bidirectional, but it doesn't need more data to carry. Okay, 8-bit or maybe 16-bit is enough for control bus. Okay, you got the idea? Is there any confusion here?
Wait.
Yes. Any confusion
Okay.
here?
No.
Okay, you got it?
Yes.
Now see this one again. Here they have given example. One second. Now here they have given example. The address of location 11110001 to be read from is first written into the MAR. Means this one. It said the address of location 11110001 to be read from is first written into the MAR. So this is MAR. Okay, one of the register. First is address moved on MAR. A read signal is sent to the computer memory. It means processor want to read data from the memory. The content of memory location, content mean data, this is data, are then put into MDR. Address put into MAR and content put here. So this is the read operation. Got the idea? Okay. Now it is telling read. Then you tell write. Here description are given regarding previous slide. The memory address MAR is loaded with the address we want to read. In this case, this one. The MAR hold address for the memory location we want to access. The MAR send the address to the memory, indicating location to be read. Okay. The memory retrieve the content stored at the specific address 1111 or 41001 and send it to the memory MDR. This is basically a description given regarding previous slide. The MDR now hold the data binary value retrieved from the specified memory location. Now CPU or the requesting component can then access the data from MDR for further processing or. So you understand all these steps regarding this. Okay, whatever going to be happen here, written here. You got the idea?
Wait,
Any confusion here? Yes, any confusion?
wait, I'm reading.
Okay, just go.
Okay,
You got it?
yes.
Okay. Now go to next slide. In summary, this summary is given. Okay. It said load the desired memory address into MAR. The MAR send address to memory. Memory retrieve data from specified address and places it in the MDR register. The CPU or other component can now access data from memory data register. So this process allow for retrieval of data from specific memory location during a read operation using MAR and MDR. Now write operation. See. It said now let us consider the write operation. Again, we will use the memory section in table 3.2. Suppose this time we want to show how the value of this was written into memory location this. So this is data we have highlighted here. Again, same memory. Previous slide, this data was read. Now, after processing, they are writing here again. The data to be stored is first written into MDR. Okay. The data is written into MDR. This data has to be written into location with address. This one. address is generated basically in memory. So this address is now written into MBR. This data has to be transferred into this address. Address carried by MAR, data carried by MDR. Finally, a write signal is sent to computer memory, and the value this any kind of data will then be written into the correct memory location. This was read and this was written. Got the idea? Here, read operation performed, and then here, write operation is done. Okay. And you
But
can first
the signals, but shouldn't the signal should come to MAR first, then MDR?
no, MDR holds the data which has to be written in memory. Okay. It says the data to be stored is first written in MDR. CPU has worked on this data uh, when it basically read from here. I'm removing this one. First computer read data from here. After processing, now it is writing on specified memory address. So it says the data to be stored is first written into MDR. Processor will write data on MDR, this kind of register, and then its address is stored in MAR. So from MAR, address will be located in memory, and then data will be written over memory. Because say finally a write signal is sent to the computer memory, and the value, this is the value, will then be written into the correct memory location. So this is the memory location, and here it's data. Got it? This is written. This is this one, and this is address, and this is content. A write signal is used. Okay, this is basic working of memory. Should I move next slide?
Teacher, memory location means like controls, right?
Memory location means like you are living in your home. Your home address is the memory location, and by yourself you are data. Okay. If somebody want to have meeting with you at home, first he or she need to have your address. Okay.
Okay.
That is why it has written data in MDR, and then written its address in MAR. From MAR, it will locate memory location, then data to be written here. It's here. Finally, a write signal sent to computer memory, and the value 10010101 will then be written into correct memory location. Because from MAR, memory location will be identified. Okay.
Okay.
Now see, this one I discussed in first class. This is basically fetch, decode, execute cycle. Just go through this one, then let me know if you don't understand. Okay. Just read
Okay.
this Yes. Have you read?
Not yet. I'm not done.
Okay. Okay, should I explain you?
Teacher, why the count instructions in the MDR are sent to current instruction register?
Okay. Now see. Wait a second. I'll show you. Now see here. As I told you, PC hold address of next instruction to be processed. PC hold address of next instruction to be processed.
Okay.
Okay. Then content of PC copied into MER. This is the first step. Now PC become empty. PC become empty.
And
Now it will increment. PC is equal to PC plus 1. PC is incremented by 1 because now it will point to next instruction after completing current instruction. Okay, that is why it's incremented by 1. Now, data stored at address shown in
Teacher?
MER is copied in into MDR. Do you know read
Yeah.
operation? Okay. Whatever it
Teacher,
holds. Yeah.
what does PC is incremented by 1 means?
Means like we can say there is a memory. I make 1 second. Okay. If you remember, this is address. Okay. This one is address and this one is content. I'm writing its address like 1, 2, 3, 4. PC is pointing here. PC is pointing here. Now CPU comes to read instruction. Okay. Like content of PC copied in MBR means this data, like is there any kind of data? It is copied into MAR.
Mhm.
So it means this data has gone for processing. This data has gone for processing. Now PC point will point here. This is called PC is incremented by 1. It means after processing this data, second instruction will be processed. After completing processing of instruction 1, second instruction will be processed. Got the idea? Now, whenever processor become free, so it will check PC. PC is pointing to instruction number 2. Okay.
Mm.
Now say data stored at address shown in MAR is copied into MDR. Whatever MAR is holding, it will copy it into MDR.
Yes.
And after MDR, content of MDR copied into CIR. Current instruction register. It means now processor is attached here. Processor is working on instruction number 1. That is held by CIR. Got the idea?
Can you say again?
I said now processor is working on instruction and that instruction held by CIR. I can write here. I can write here. Processor is working on instruction number 1. Which is held by CIR. Got the idea?
Teacher,
Yeah.
processor also means CPU, right?
Yeah. Processor means CPU.
Okay.
So CPU is working on instruction number 1, which is held by CIR. Now, after completing instruction number 1, CPU will go to again PC, and PC is pointing instruction number 2. Got the idea? Got the idea? So
Yes.
whenever CPU picks instruction number 2, PC will update. Now it will point to instruction number 3. Okay. And again, same process start. Content of PC copied into MAR. Now PC become free. PC will update it, means it will point to next instruction, which need to be processed. Now data stored at address shown in MAR is copied into MDR. MAR holding the address of data. Okay. Now content of MDR copied into CIR. And on CIR holding that instruction, it has to be processed. It is now current instruction. Now CIR means current instruction register, on which CPU is working. Right. Okay.
Okay.
So that you can understand, you can go through here again. Okay. Yes.
Yes.
So now you got it.
Okay. Okay, I have to start.
So enough for today.
Yes.
So see you next class.
Okay. I love this.
Allah Hafiz.